shows that there is a wide scope of research topics on robotic sailing covered at your institute. It will be presented by Lars and Hertel. It's about data mining for optimal sail and rudder control on small robotic sailboats.
Okay, so welcome to the talk with the topic data mining for the optimal performance of small robotic sailboats. Basically, what is this talk about? We have 4 identical micromagic sailboats, as you can see in this picture. In case you don't know, these are very small boats with hull lengths of nearly 50 centimeters. And now we want to use data mining techniques in order to optimize the performance of these boats. We define the optimal performance on the basis of 3 criteria. First, the boat speed. We want to increase the boat speed, so the boat should sail as fast as possible. Second, the course stability. That means that the boat should sail the course we set in before. And third, energy consumption, so that especially rudder and sail movement should be reduced. Now, why do we use data mining techniques? As we all know, robotic sailing is an intricate task. And the biggest problem is that no mathematical model for sailing exists. So we can't simply calculate the optimum performance or even the behavior of the boat. And another problem is that optimizing the performance of the boat is a multi-criteria problem, because it is not even clear what the optimal performance is. You can say, okay, the boat should go as fast as possible, but when it's going into the wrong direction, there's no win. And to optimize the performance of the sailboat, there are many parameter settings you can adjust. For example, the keel weight, the keel position, or the controller for rudder control or sail control. Now, the good news is that the data can be stored, the sensor data can be stored and analyzed later on using data mining techniques. And that is what we've done. Now, what do we want to analyze? As I said before, there are many parameter settings, and now we've chosen several of them. First of all, the keel position. The micromagic allows to mount the keel bow in 3 different positions. Forward one, central one, and an aft one. Second one, the keel weight. We have several keel bulbs ranging from 370 gram to 600 gram. And third, the sail position, especially the relation between the jib and the mainsail. So is it better to open the jib a bit more or to close it a bit more? And fourth and fifth, the rudder control. How often shall we adapt the rudder and how much should we adapt it? Now the most important part, how was the data collected? We collected the data by what we will call course races. And what is a course race? In a course race, several boats compete against each other by sailing the same point of sail at the same time. So we do have 4 identical boats, and as you can see here, there's 3 of them sailing the same course, in this case a broad reach course, and the boats are trimmed nearly identical, except one parameter is changed. So for example, they are trimmed exactly, but the keel position is different. And then we can later on analyze the influence of the keel position on the performance of the boat. Okay, and this is what we have done for every single course. So here you can see a broad reach course, and this is a closed hold downwind course where we use a wing-on-wing sail. sail position, and beam reach course. Now, as you might be familiar with the surrounding, it's in Lübeck, the Wackenitz, where the WRSC, the last WRSC was. So there are, well, not that high waves and wind speeds to 14 to 20 knots. Okay, now we have some key data for the data collection. The data collection took place in the period from October 2011 to April and 2012. And the communication frequency between our laptop and the boat runs on 5 Hertz. So every 200 milliseconds we get a new record of sensor data. And now in these 7 months we have collected nearly 2 million records from the boat. And this resembles approximately 110 hours of sailing on 55 different days. Now, as I said before, the wind speed on the Wackenitz ranges from 4 knots to 40 knots, maybe, and the waves are up to 20 centimeters, which not seem that high, but for small boats, it's not that less. Okay, now the important part, the results. Here you can see a polar plot with 3 different diagrams, which resemble the mean boat speed in knots, ranging from 1 knot to 2.2 knots. And the 3 colors mean, or the data for the 3 different colors were collected on different wind speeds. So the black one corresponds to 5 wind speeds of 5 knots, and the red one to wind speeds of 8 knots, and the green one to wind speeds of 11 knots. Now, as you can see, basically the beam reach and broad reach courses are the fastest courses, but the downwind course is not that slower. And obviously, while the wind speed increases, the boat speed increases as well. Okay, now the course stability. We define the course stability on the basis of the difference between the course we want to sail. For example, if we want to sail a 90 degree to the wind, but we sail actually 100 degree, then the deviation is 10 degree, and this is plotted here. So 0 is if we sail the optimal course we wanted to sail. Now you can see again 3 different plots for wind speeds ranging from 6 knots to 11 knots. And interestingly, the close hold course is not affected by the wind speed. So you only have an offset of maybe 7, 8 degree. But especially when you come in the downwind region, the course gets more unstable with increasing wind speed. Okay. Now, what our results showed when we performed the course races and analyzed it later on. If you want to increase the boat speed in moderate conditions, ranging from 7 to 9 knots maybe, a middle keel weight that is 470 grams is preferable, as well as a central keel position. Interestingly, if you adapt your rudder less often, your boat gets by far faster because every rudder movement slows down the boat. And even more interestingly, the speed is relatively insensitive to small changes of your sail. So, for example, if you keep your jib a bit closer, it does not affect the speed at all, or nearly does not affect the speed at all. Okay, you have a sip. Now, if you want to increase the course stability, the most significant result we got was to move the keel aft. So if you use an aft keel position, you can sail your course by far better on a more stable course than if you set your keel in a central or even forward position. And a light keel weight was preferable because the rudder, you could easier steer your boat. Now, sail position. As I said before, it does not have an influence on the speed, but it does have an influence on the course stability. So if you close your jib a bit more, like 5 to maybe 10 degrees, than your main sail, your course gets by far more stable. And obviously, if you use more rudder adjustment, then the course is more stable as well. So now the energy consumption. If you want to decrease the energy consumption, you should especially try to reduce the amount of rudder and sail control. This can be done if you use fixed sail position. So, for example, we wanted to sail a downwind course, then we set the sail on a fixed position and just go until we reach a waypoint. And if you want to sail a beam reach course, we set the sail again to a fixed position, keep this and adjust the rudder to keep or to maintain this course angle, and then again until we reach the waypoint we set again. Therefore, you can reduce your sail control tremendously. And as we found out as well, you should adapt the rudder movement to the point of sail. At first, we used a global rudder control, so we set a P controller to every single point of sail. But if you adapt your rudder movement to the point of sail, you can reduce the rudder movement because the closed hull course does not need that much movement that, for example, a double. Okay, to sum up, robotic sailing is an intricate task, and we tried to use data mining techniques in order to optimize the performance of the robotic sailboat, and we defined the optimal performance on the basis of 3 criteria: the boat speed, the course stability, and the energy consumption. Now, as we found out, the boat trim influences the speed, the stability, and the energy consumption of the course. Some trims and controls influence one parameter more, and the other one the other one. And to sum up, it is preferable to use a reduced set of parameters. So you should try to find a parameter setting which is stable, leave this parameter setting, let your boat sail a course, and then change it when you reach it. Okay, thanks for your time.
Thank you very much. Impressive for me. I would like to have 4 or 5 identical boats to test, but the boats are both too heavy and too big. But that's probably the biggest advantage of the micro magic boats. Any questions?
Very interesting talk, and seeing the difference in performance for these changes. One question, first question, when you were looking at the changes in keel position, did you note the change in bulk? Did you note the changes in trim of the boat, up and down trim?
No.
Or the amount of sinkage in the boat or the waterline length change?
No, we just adapted changed one parameter at a time. So if we changed the keel bar position, we set everything else the same.
Okay, but the boat would trim when you changed the keel bolt position, or did you move other weights forward to keep it at the same trim? Meaning the back, you move the keel back, the bow comes up. Did you keep that? Did you move other weights forward to keep it trim?
No.
Or did you allow the bow to come up?
We allowed the bow to come up.
Okay. And the second question is, the polar plots show distinct asymmetry from port tack and starboard tack. Did you find that the boat was asymmetrically built? Or what do you think is the reason for that asymmetry?
I think the reason for the asymmetry is the test area, because the wind is not that constant there, and there is a preferable course if you, for example, port or tack. I don't know which one is preferable, but I think it's the surroundings of the waggonets which influence this performance of the boat. But I can't guarantee that the boats are built exactly the same, so there could be an error as well.
Another question? Please.
About the energy consumption, do you have any comparison between the energy consumption of the sail for the sail and the sailboat, the rudder sail? I mean, in percentage, for example.
We ran some tests on shore to see how much the influence between the adjustment of rudder and sail control was, but we couldn't test it on the water because the energy consumption was just too low to be significant. Therefore, we had to sail maybe 12 hours in order to see a certain difference. Therefore, we just tested it on shore.
Yes, but how did you measure the energy consumption? Just measuring the capacity of the battery?
Yeah, the voltage. We just measured the voltage.
So you didn't measure the current from
no.
that goes to the sail?
No, we used identical batteries, and we calibrated them before, and then we thought, okay, the voltage would be.
You measure the time to empty or the time to reach.
One more question? Yes, please.
It's a logistic question. How do you manage to launch the 4 ships to be able to compare their performance at the same time?
We used one laptop and just started our program 4 times and connected to each single boat. And then we set a circle with a center. And first of all, we let every single boat circle around the center point of the circle. And then we said that, okay, in 5 minutes, every single boat has to sail a closed hold course, for example. And then reaching the time, all the boats sailed the closed hold course, and when they left the circle we defined, they had to return to the center point again. And then we could start another course race. And then we analyzed later on the performance of the boats.
When you analyze core stability, what kind of controller do you have for heading, for example? Do you change that all? So if you just change, for example, the position of the keel, what kind of controller are you using? Because if you adapt it,
we say, okay, the boat has to sail on a wind course, for example, 90 degrees to the wind, and then we use the rudder to maintain that angle, and that we use for every single boat while performing a course race.
so you are evaluating how your change is adapting to the control that is implemented, right?
Yes, exactly. Yeah, exactly. Yeah.
Okay.
May I have a?
Yeah, of course. Yeah.
No.
Not all of us are in a comfortable situation to have 4 boats to make such course races. Do you think, or to what extent do you think, the findings you've presented valid for a boat which is 20, 50 or 100 times heavier, for instance?
I think there's a big difference between these 2 kinds of boats. Between a large boat is by far more robust. But if you sail a course, for example, beam reach, you don't have to adjust the rudder and sails that often. But for the small boats, even a small change in wind direction can change the course of the boat totally. And therefore, you have to adapt your sail and rudder position actually quite often. And therefore, I don't think that the results can be adapted to bigger boats, but you can try out.
No, but you didn't present absolute numbers, yes?
Yeah.
That for sure they're different. But general findings, you mentioned that you need to trim the rudder more often on downwind course.
Yeah.
I mean, that's from my experience the same with our boats.
Okay.
And do you think that, I don't know, you have a slide where you point the findings. Do you think that in general this could be a proper testing environment also for us with heavier boats to optimize the control?
I do think so. I mean, we collected a lot of different data in a lot of different situations, and you could use that database for trying to test your boat on the basis of that. I can give you the data, and then you can have a look if it works.
I guess you should probably use the procedure, and then you could, from the same kind of procedure, and take your own conclusion from your own boat.
Okay. Thank you very much. I guess Colin will tell you that.
So it's lunchtime now, back here at 1:30. I think food is served downstairs today, and I'm not 100% sure. Yeah.